This video is brought to you by StarCharge, the largest EV charging manufacturer in the world. They are also a provider of residential and commercial battery storage with microgrid solutions. This video is also brought to you by Kempower, the reliable, quick, and scalable EV charging solution for everyone and everywhere. Hello and welcome to another Out of Spec Reviews video. You join me and my colleague Ryan to discuss all things charging the Cybertruck. I've been jamming you with 3-hour-long videos all week with full tours and driving impressions and crushing carrots in the hood, which was really silly. I agree, but everyone said crush some carrots in it. So we did it, and there were some other things in that video. I get why people want the nerd stuff. That's what you're getting in this episode. This is all about charging the damn Cybertruck. And there's some good, there's some bad, there's some really bad that we're going to be getting into in this episode, and definitely some suggestions from our side for Tesla to improve some certain things. For those of you who don't know Ryan, he's sort of a resident nerd along with me. We love analyzing charging data. And so right off the bat, Ryan, I mean, you've crunched all the numbers on the Cybertruck charging. Do you want to give everyone who doesn't want to watch this whole video sort of a thumbs up or thumbs down right off the bat? How does this thing charge? Thumbs middle.
Right where
Okay.
I'd put it. Right where I'd put it. My takeaway is that, genuinely speaking, I think all of the current EV trucks are really competitive, and it's remarkable how similar they are. It's obvious how clearly they just benchmark each other.
And how bad they are, like compared to other cars. So
certainly.
There's a lot to get into here, but I totally agree with you, especially after crunching the data, because sitting there at the charger, it almost felt worse and more annoying than what the data is suggesting at the moment. So this is why we log everything and reserve judgment until we actually have a chance to review the logs. What I want to do first is explain the couple different ways of charging the Cybertruck. I want to explain what the Cybertruck can actually charge on from a DC charging hardware perspective, and then we'll get into analyzing the curve. And a lot of our audience, especially those watching this video, understand that you can charge an electric vehicle with an AC, sort of an electric vehicle supply equipment, a mobile connector, or a wall box, or a DC charger. And the AC unit's up to 48 amps on this particular one in terms of the onboard conversion capability, the onboard charging capability. And it uses an integrated PCS system like we've seen from Model 3 and Model Y. And this PCS system handles the series to parallel switch. We'll get into that for sure. It handles the outlet situation on the vehicle where you can actually do bi-directional charging as well as power port in and out. And one interesting limitation I should mention is anytime the vehicle is plugged in and charging, all of your 120 volt outlets and your 240 volt outlet are inoperable. They do not let you use the outlets while you're charging. So you get to a charging station, you plug it in, you want to charge your laptop to edit a video, and you're like, what the heck is going on? The outlets won't turn on. Now, I've already, the only thing I've really tweeted to Drew Baglino, who's head of energy for Tesla, more or less, was about this particular issue. And he mentioned there will be an upcoming firmware update to allow roughly 5 kilowatts, just under, of power while charging. And I think that's reasonable. I think we can all agree that that's at least better than the nothing we're getting right now. So I can't wait for that software update to come. But onto the charging of the Cybertruck. Charging is a 48 amp onboard charging capability, which, we have to look at the competition in this space. The Hummer EV has a 240 kilowatt hour gross, 212 kilowatt hour usable battery pack. That is pretty much double the Cybertruck's 124 kilowatt hour 4680 Gen 2.3 cell battery pack. Now, the Hummer EV that we tested also only had a 48 amp onboard charger, which means it took like a day to charge if it was dead to full. Now, granted, most owners, I think, Ryan, you'll agree, are not doing 0 to 100% charges on AC. You're just topping up and replenishing the juice that you used. But especially when we start talking about trucks that are pulling heavy loads and going through heavier duty cycles, it's really nice to have an 80 amp onboard charger. And currently, the only electric truck that offers it is the F-150 Lightning, as far as I'm aware.
Yeah, I believe that's accurate. And I'm 100% in the same boat. I think every EV should be able to fully charge from 0 to full in 10, 12, maybe 13 hours at most. I, there are situations where you plug in empty and you want to have a full battery the next day. And if it's taking 2 days to do that, that's pretty rough, or a day or 18 hours even.
Yeah, I totally agree. Just having, especially with big batteries, huge premium costs for these vehicles. I'd love to see an 80 amp capable onboard charger. And so I think Hummer EV will get it. Silverado EV will get it, but they currently don't have it, is my understanding. And it was just like a supplier thing. It wasn't ready in time. In Tesla's case, they don't even sell an 80 amp EVSE anymore. The maximum they sell is that 48 amp wall connector. So it's unlikely we'll ever see them go back to the high power AC days that they used to have. So I don't want to spend too much time on AC charging, but I do think it's important to mention, since that's where 90% of most people's charging is going to come from, is from just an AC connection to an electric vehicle supply equipment. And in the Cybertruck's case, 123 kilowatt hours, 48 amps, it's livable. I don't think anyone's going to complain about it. But certainly if Tesla goes with any bigger battery, they need an 80 amp onboard charger. Just my impression. And that PCS system within the Cybertruck is responsible for a bunch more, but I actually want to reverse out a little bit and talk about the battery pack just slightly. The battery pack of the Tesla Cybertruck is a modular system, if you will. There's 4 sections of the battery pack that are wired together in series, and each section is roughly 200 volts nominal. So you have 200 volt, then you wire another one in series, you have 400 volt, another one you have 600, and another one you have roughly 800 volt nominal. It's just under 800 volt nominal for the Cybertruck's operating voltage. And the benefit of having this multiple bricks within the battery pack comes to the ability to charge on charging equipment that does not meet the pack voltage. And this would be legacy charging equipment, even current superchargers, as an example, are really the main reason they have this limitation. And we'll talk about the control logic here, I think, actually just now. We may as well just get into it. So within the PCS system of the Cybertruck, there's a way to configure the operating voltage of the battery pack from 400 volts to 800 volts. And under normal conditions, even when AC charging, when driving around, the truck is operating as an 800 volt system architecture. In fact, we've logged the operating range of the truck from 690 volts dead to 820 volts full, plus or minus a little bit. And ultimately, that seems like a pretty reasonable operating range. It's right up there with higher than Taycan, higher than EGMP, lower than Lucid, but I think also may not freak as much charging equipment out when we start getting into the third-party stuff, because some of the stuff is hard to top charge the Lucid, fingers crossed. And so, yeah, I mean, this makes sense. So when we talk about the changing the operating range of the voltage, and we talk about splitting the pack, the Cybertruck in certain conditions when charging on DC equipment has to go from an 800 volt and basically split in half and take 4 of these series wired packs and wire 2 of them in parallel. So you have, 2 200 volt bricks here, and then another 2 200 volt bricks here, making a 400 volt system architecture. You have 400 volt, boom, lock them together rather than doubling the voltage. So everything is 800. The reason you would do this is because when you're DC charging the vehicle, you're using an off-board charger that is basically doing the same thing that onboard 48 amp onboard charger is doing. And it's doing it in these giant cabinets off-board that can handle way more conversion power, matching your battery pack voltage, actually going just slightly above your battery pack voltage so the current flows into the battery, and then charging and dumping current through a cable into your battery pack directly. That's why it's called direct current charging, direct current fast charging, DC fast charging. And there are a few different types of chargers out there. The first is, let's talk about what the Cybertruck can actually charge on at the moment. And it can charge on a version 2 supercharger, which are the ones with the non-liquid cooled cables on them at the moment. They have the silver collar ring, and they're typically in pairs, 150 kilowatts. When you plug into a version 2 supercharger to the port, the Cybertruck actually has to go, whoa, wait a second, this supercharger can't get up to 800 volts. It's just not possible. So it has to split the battery pack, and you'll hear a ka-chunk every time the Cybertruck makes a little tick, tick, And this splits the battery pack down to 400 volts, roughly. Again, it's going to be like what was the operating range in split pack?
At the bottom, we saw about 360, 365, and then at the top, about 410.
Right, exactly. And that's where we got the operating voltage in 800 volt. We just doubled that up. And so, yeah, so it's going to basically say, oh, charger, get down to 360 volts when you're dead, dump in a bunch of current. The version 2 chargers can do, 500, 600 amps, something like that for a short period of time. They just juice that thing up, and then you're good to rock and roll. The Cybertruck can also charge on version 3 superchargers. That also surprisingly has a limit of 500 volts. And I believe Tesla's communication is about 469 volts maximum of their charging equipment. So unfortunately, that's what every supercharger is out there today. The Cybertruck always has to go into, wait, I'm plugging into an old school, low voltage legacy charger. Let me switch from 800 volt to 400 volt so it can directly charge the battery. Now, this does not mean you can charge faster. It does not mean because you're charging 2 separate battery packs in this case. It is just a change of the voltage, and you're going to require a lot more current, a lot more losses by charging this way, because if you have your you have your voltage, you have to double your current to get the same amount of power. And this thing will hold 700 amps from like 0 to 10%. It is just jamming the juice through these little tiny version 3 cables. You'll actually start to overheat the cables with the Cybertruck way more than the other vehicles, because the current request is higher. It's got a bigger battery, so it's holding that peak rate for longer. And you just need to wrap the cables with a cold, wet rag, or honestly, charge it till the cable smokes, unplug, and move. And yes, the version 3 chargers are liquid cooled, but they can't keep up with 700 amps continuous. And so they do derate based off of temperature.
Yeah, absolutely. It's insane amount of amps.
It really is. And I was going to talk about something else with regards to version 3 charging at the moment and split pack, but I don't remember what it was. And okay, let's just continue on. There are version 4 superchargers that people claim are out there. At the time of this recording, there is no such thing as a version 4 supercharger. I want people to hear this. No such thing in any market, in any country, installed publicly that we have seen. Every version 4 supercharger that we have seen has just been a dispenser. It has been a difference in the handle. It's been a difference in the cable. It's a really nice immersion cooled cable. It's a longer cable. Okay, great stuff. But holy smokes, you really have to be careful saying like, oh, but Cybertruck on a V4. No such thing. Okay, so version 3 charging is the only way to charge this one. When you plug it into a version 4 dispenser, you will have the exact same charging experience as the version 3. I mean, Ryan, you run Rate Your Charge. You've seen a lot of confusion around this. What do you think Tesla's doing? Why do you think there's a delay for version 4 charging?
I think that's a really good question. I think there's probably 2 likely answers. One of them being they have the dispensers ready, they're upgraded, they're better units, and they're much more capable of handling vehicles with different charging port locations. So they just want to get those out as soon as possible, and they're still working on the actual V4 cabinets. I think that's probably the most likely scenario. It's also possible that there's a supply chain issue, but I know Tesla does a lot of stuff in-house, so I think that's less likely.
Yeah, I would agree. I think that's a reasonable assessment. They had that part ready to go. V4 may not be ready to go, so they're just getting this out. Maybe they'll retrofit the power cabinets or do something to allow higher voltage. Now, what I really hope Tesla will do for the existing version 3 sites is to upgrade them to support high voltage natively, because it's not just Tesla now. They are now serving third-party or non-Tesla electric vehicles at their charging network. They've convinced Hyundai, Kia, Genesis to switch. They've convinced Lucid to switch. They've convinced Volkswagen Group with e-tron GT and Taycan and others like Macan EVs, high voltage vehicles that are going to be severely limited on the existing charging network if they don't go to higher voltage. And every vehicle has a different voltage boosting strategy. And we look at how Cybertruck goes to the split pack approach. To me, this makes the most sense. There are 3 vehicles on the market that do split pack, as far as I'm aware, at least in our market. Maybe in China, there's a few others. But there's the Macan EV Q6 e-tron, that PPE platform that goes into a banked charging, where it's a high voltage car, splits pack, and then it can accept a charge at a lower voltage charging station. And then there's also the Hummer EV, except the Hummer EV and Silverado EV, their double stacker does it in the opposite direction. And they are normally a 350 volt nominal operating system. And then they double when you plug into a DC charger up to about 700 volts, so it can get higher charging power. Up to that, I think I've heard 377 kilowatt peak charging from someone.
That's okay, I guess.
We love the big boy charging. That's the fastest charging EV on the market by far. I mean, Lucid's 351, no slouch, especially with the size of that battery. But Hummer EV's taking on a lot more energy, less stress on the battery from a C rate though. And of course, the Cybertruck is the last one that does this split pack charging. The other strategies actually come from, we can use Taycan and e-tron GT as an example, where they have a big box in the vehicle that actually splits the voltage. So it can route the, basically take, the charger doesn't know the difference, but it would say, oh, hey, instead of an 800 volt car, I'm a 400 volt car. It goes into the box, and then the box actually boosts. It's called a booster, boost the voltage up. Lucid works this way with the Wonder Box as well, and that's limited to 50 kilowatts. Taycan's limited to 50 kilowatts, but can be upgraded to 150 kilowatts. And then the Koreans do it pretty smart with this onboard booster using the rear motor's inverter. And there they can basically pull full voltage from the charger and full current from the charger up to its maximum conversion capability, and then charge the battery pack using that rear motor silicon carbide inverter and basically regenning the battery pack to charge. It's fascinating. I actually charged a Kia EV9 at a supercharger recently with this technology, but the maximum it could charge at was 84 kilowatts. And others are about 100 kilowatts. And then EV6 GT is only 45 kilowatts. So they're all over the map there. I don't understand the eGMP communication issues and also some of the boosting issues, but I'll have a full video on the EV9 charging coming very soon. So in terms of when the Cybertruck is charging on the DC equipment that it can charge on, it's kind of doing it in the best way, where it's not using lossy or expensive or space and weight intensive components. It's just going ka-chunk and splitting the battery pack and charging it directly. Ryan, what's your opinion of the different ways to match to older legacy lower voltage charging? Do you think this is the correct approach?
I think it's really interesting. I think I'm actually a bit more partial to the Hummer EV approach, because to me, it seems like that might be a bit more advantageous. There's a lot of systems components designed for 400 volts, so you can take advantage of that. And then you can take advantage of 800 volts, which means lower amps. It's just less stress on the battery, easier for the cable, easier for the charger. So you get the advantage of charging, and then also can use standard equipment and supplies and parts.
Yeah, from a platform engineering perspective, the Ultium platform supports primarily their vehicles like Lyric and Blazer and Acura ZDX and all of these ones. So they're all 400 volt system architectures. So it didn't make sense just for the big battery Silverados and Hummers and Escalade IQs and future, whatever else they're going to do to make all the components 800 volts. They could save so much money and use the same 400 volt components, but then gain that faster charging capability. And they do some cool things in terms of the AC compressor and other loads that have to run when it's an 800 volt. I'd actually be curious to see how Tesla does it. I was talking to one of the lead project managers of Macan of PPE, and he mentioned that all of the components that will be running when the vehicle is charging in banked and split pack actually can handle the voltage range of the entire split. So it's not like they need to pull off one side of the battery and then they get slightly out of balance. They have to switch. This is why Hummer EV stops charging sometimes, because it has to switch which bank the medium voltage electronics pull off of. It's all pretty fascinating. No need to dive into that. That's a whole nother video. But that's how Cybertruck split packs. And there's other high power, high voltage, high current charging equipment installed everywhere in the US now. Every Electrify America station is a 500 amp capable charger up to 1,000 volts. Now, it can't do both. It will obviously derate the current as voltage goes up because you still have a conversion maximum of around 370 kilowatts or so, 360 kilowatts, something like that. They're labeled at 350. And ultimately, what I wanted to do with the Cybertruck was, when I was doing my testing, was to max out its charging capabilities. When we show you the charging curve here in the moment, this was the goal. So literally the first thing I did was I met Ben in a parking lot at an EVgo, one of the Ultium branded stations, and they use the Delta high power charging station. And the reason that I like the Delta high power charging station is they are 540 amps. So it's actually the highest current, highest power public charging station publicly available in many locations. There's actually an experimental charger in Phoenix by New that's like a 700 amp charger that's publicly available. I just found that the other day. That was cool. And just like a couple maybe other behind the fence stuff. But basically those EVgo Ultium Delta high power stations, those are the ones that I know I can rip. They give me the voltage readout, gives me all the data. So I was like, Ben, you got to meet me at this site. Bring the Cybertruck, preconditioned, 10% state of charge. Let's make sure we can charge this thing, and then we'll run it down to zero. And the first thing that happened was I backed the truck up to the charger, and I grabbed my CCS adapter because, of course, they're not NACS yet. And I took my CCS adapter and boom, didn't fit. It crashes. It does not interface with the NACS port because the CCS adapter is quite fat, and it hits this fender lip of the Cybertruck. And I'm like, what's going on here? This is stupid. And so I couldn't get it to CCS charge. I'm like, this sucks. I need this thing to charge. And then I went in the system of the truck and I said, hey, let me make sure CCS is enabled. And it shows CCS enabled. And essentially when it says CCS enabled on the screen, it means that the vehicle is open to PLC communications rather than running single wire CAN, what Tesla normally is. And single wire CAN is how every supercharging session operates. PLC is basically communicating with ISO 15118-2 at the moment. And I guess they could do a couple other communications on single wire or on PLC, but ultimately that's what I was looking to make sure that the vehicle had enabled. Once I made sure it was enabled, I was like, well, I figured if I can just plug the adapter into the charger, then it should work. But before I did that, I thought, Kyle, we are going to possibly blow something up. Reason being, the official Tesla CCS adapter at the time of this recording, I have no doubt they're going to have to release a new adapter. This is just pure speculation, but I think they need a new adapter. The current adapter is only rated nominally up to 350 amps, which is just not enough. Maybe it's 500. No, I'm pretty sure it's 350 amp nominal, but that's okay. They derate for temperature. It's not perfect. It's still a little sketchy. I've burnt one up before. It's like, okay, adapters are scary. We'll do another episode on that. But it's also only up to 500 volts. And so I think part of this design of the Cybertruck, whether it was intentional or not, limits the use of the official 500 volt Tesla adapter on the Cybertruck. Now, this is no problem for Model S Plaid or any of the other vehicles that Tesla makes because fully charged, they're 450 volts. That's the most my Plaid ever goes to. Cybertruck goes up to 820, which is far outside of the voltage operating range, which could actually lead to some dangerous situations because it's not insulated for this type of high voltage, or at least it's not rated for it. Whether or not it can handle it is another story. But I thought, well, I'm going to find out either way. Let's just go blow something up. So what I did was I ripped the side molding off the Cybertruck. We unscrewed the whole charge port. I removed the power charge port door, and I went through the process. You know, the vehicle thinks it's connected. The charge port door actually comes off of the charge port. And so, you know, I opened charge port, unlocked charge port. The thing opened up, even though it was dangling off the side of the truck. And I plugged in the CCS adapter, plugged in actually the Huber Schooner cable to the CCS adapter, and then interfaced it into the vehicle, tapped my EVgo card. By the way, they sat there, normally in blue, vehicle's blue, it says waiting for charger. Charger says waiting for payment. All is good. I'm like, hell yeah, we're going to get to see this thing charging at high voltage. First time a Cybertruck would have ever charged without going in a split pack. It would have charged in series mode. And it didn't work, failed communications. And I called EVgo. Of course, we're really close with the guys over there. and I was like, guys, can you pull the logs on this? They're like, pulling up everything. We're going through the communications. I actually saw some of the EVgo guys today, and they're like, thank you for doing that, but it was kind of inconclusive. We need some more testing. So if there's a Cybertruck I can borrow in the Southern California area, I'd love to bring it by the EVgo labs and see if we can actually get it to interface with some of their charging equipment. It would be really a fun video to look at how we debug charging issues like this, especially in their laboratory. So I did a couple different starts, tried to get the things to go on the Delta high power, and it just was not working. Just was not working at all. And then I thought, okay, well, NACS has a 500 volt physical port. And then there's also 1,000-volt physical port, which I'm sure the Cybertruck has the new updated, I think it's a little bit deeper in the back. There's some physical change to allow the higher voltage version. And that's pretty much the NACS port that we're going to be using across the country. And for all future product. But there's no way for the vehicle to actually know what you're interfacing with, which actually might be slightly dangerous because it means 500-volt adapters could be used on high voltage applications in the future. Again, another topic, but something to consider. And ultimately, I could not get it to charge on that particular charger. Now, I could have gone to different chargers and different brands, or even found a 500-volt maximum charger to see if the Cybertruck was just software limited to not go into series mode. It knew you weren't plugging in an approved adapter, and it said, no, you can't charge on these. But what I was most looking forward to with the Cybertruck was not being the dude who plugged it into an old school limited supercharger. I wanted to go to a new, modern, high voltage, high current charger to really get a proper charging log. And it just didn't work on that particular Delta high power. If I had more time, if I didn't have to range test it, if I didn't have to do other reviews of it, I would have left the whole thing dangling down the side of the truck, went to a ChargePoint Express Plus. I would have gone to an old, maybe an EVgo ABB low power 50 kilowatt site that's limited to 500 volts to see if the Cybertruck was just not liking the voltage range, or if there was just a pure communications issue, on everything. So it's quite inconclusive. But I would say, at least I can say it's kind of funny to think about. There's a very real possibility that Cybertruck does not support NACS, because NACS uses PLC ISO 15118-2 and not single wire CAN. I mean, Ryan, what do you think about that? That's a video title right there.
That would be wild. I cautiously optimistic that they're just software locking it out, but who knows?
Yeah, I mean, I think almost completely software locked. There's no way that they're going to lock Cybertruck from not supporting NACS. But Tesla could just say, hey, we just released this truck. We want all the charging data on our superchargers. We really, we don't even think our early owners, who are mostly employees, by the way, or very close friends of the company, are even going to be going to third-party chargers. But again, this is the Tesla way. They're releasing an unfinished product, then expecting software updates to get better. At least at the time of this recording, it appears that it's a possibility that Cybertruck does not support NACS. It does not support J3400. So that's wild to me.
It's a crazy reality.
Yeah. Anyway, what that meant was all of our charging logs today are plugged into the highest power charger that the Cybertruck will accept. Now, in the future, it's very possible that the Cybertruck will accept more power at other stations. With that said, Ryan, should we finally get into the damn charging curve of this thing?
Let's do it.
Okay, I promised everyone this is going to be a quick video, but that's a long bit to explain. Here we go. Okay, this is not actually I want to get into this chart in a moment, but this is what everyone's going to be familiar with right here. So this is the Cybertruck's charging curve. By the way, Ryan has gone through an immense amount of data to make all of this available to you, the public. You go to outofspecstudios.com. You can go to any of our testing procedures that we do, and now you can visualize the data, break it up by vehicle make, break it up by vehicle type, and then overlay charging curves of competing vehicles to help make a better buying decision. And it's not perfect. I'll be the first to admit our data is collected in sometimes not perfect ways, and I'm adapting how we do these things over the years. And we have to go back and retest some of the vehicles that I didn't really like how we did the procedures on it. But this is ultimately the best that we can do at the time of this recording. And it is going to be a focus this year of really dialing in our numbers and metrics so that we have raw, accurate data to the best of our ability to bring to you guys. Anything before we go into this charging curve that you want to mention about all of the hard work you put into this, Ryan?
Only thing that I want to mention is actually just specific to the Cybertruck here. And if we are showing the video of the charger, there might be some slight discrepancies here and there, because what we've done for this one is piece together a few different charges to see what the theoretical maximum would be. And that's what this result that we're looking at right here is. And this is actually something we've done with a few other vehicles. Notably, if you remember the Rivian, when we tested the 500 amp update, we had to splice together a few different charges to get the optimal charging curve. So that's what we're looking at here.
Right. That's a great point. I mean, a lot of people will consider the charging curve of the vehicle to be what can it handle starting at, let's say, 10% to 80%, including the thermal derating, because some vehicles overheat, some cables overheat. Ultimately, what we wanted to do was to say, if there are no variables of temperature, what is the theoretical maximum at any given state of charge point that the truck can accept in terms of power? That way, when you're charging at a supercharger in your Cybertruck and you're at, I don't know, 21%, you're only getting 210 kilowatts, but we know it can hold 250. You can say, okay, either the battery's cold, the battery's hot, the supercharger site is limited, or the cable has derated based on temperature. Those would be the four things that would indicate a lower performance. So this is the maximum charging curve that we could get out of the Cybertruck over multiple charging sessions. Now, I will say, actually, if I just ran up to a charger and plugged in, went 0 to 100, it would not be far off of this. Most of the data was pretty aligned. Wouldn't you say, Ryan?
It is almost identical between like 19 and 23%. It was a little bit slower when you did your full charge. That's basically
Right.
it.
And I think actually what happened was the supercharger handle got hot in that region and derated a bit early. But I had other charging sessions to say, nope, this is actually how long it holds full power to. And to be clear, there's also other metrics here at work that some car companies do, especially Lucid, where they reward AC charging by giving you higher power DC charging, which means that if you DC charge over and over and over, it might start pulling in your peak or pulling down your maximum rate. And then you can actually earn back your DC charging profile by AC charging a few times. So Lucid works this way, which I found out recently and I find really interesting. And I think part of our testing procedures going forwards is before we do charge analysis, we may want to AC charge the vehicles for a few cycles just to make sure that this isn't becoming an influence at all. At least on these Cybertrucks, Tesla doesn't do that too badly, but it's possible that there is some degradation of performance with a bunch of DC charging. But typically with Tesla, we're talking over many megawatt hours. And usually this is just on the early Model S vehicles and early Model X. Most of the new stuff, they just let you rip on it over and over. So this is the charging curve of the Cybertruck. And I'm just going to pull it up here and show you. Basically, you can see, whoops, I totally went and overlaid everything. Excuse me. Let's just go here to the Cybertruck. And then I want to
overlay. A great
overlay
opportunity for me to brag and show off. You can see in the top right, the vehicle groups. You can select what's relevant and then select whichever vehicle you want and need. I'm pretty happy about this.
I am too. I really like this. So basically you have, your SOC over your kilowatt, or I should say kilowatt over SOC. And this is sometimes mostly what we try to do is say what's coming into the port of the vehicle. And then sometimes we'll also do some that say what's going into the battery pack. And we'll make note of that. Some vehicles, we don't know what's going into the battery pack. Tesla, for example, only shows what's coming into the port. And then there's going to be some ancillary loads that the charger will overboost and compensate for in those processes. So here we have full power to 25%. So if you're road tripping a Cybertruck, again, I plugged this truck in at 0% many times. And you can see it ramps up 0, 1, 2, up to 250 kilowatts and rips. And it pretty much just goes a little slow at the beginning, as most Teslas do. And then, whoa, even at very low states of charge, it goes. My Model S Plaid, for example, is also a relatively new battery pack. The Model X Plaid that I'm driving, my dad's car this week, relatively new battery pack. I think only had a couple thousand miles. They don't actually ramp up to full power until 10%. So Teslas seem to hold full power for a very short period of time. In those cars, it's 10 to 36%. In this case, it's roughly 0 to 25%. So almost the same percentage range of the battery they're holding full power. Cybertruck just does it down low. And what that means with Cybertruck is if you're road tripping it, you want to get this thing as low as possible. You want those 1% arrivals, 0% arrivals. And just, if you're going to run it down to 0, you can watch the power meter on the screen. If you really get a lot of dots coming in, then just keep in mind BMS miscalibration may happen. They may not always have a buffer below 0. So just watch the power limit. That's a good way to avoid, getting a confused BMS. And then after 25%, it just hits a wall. Bam, down. We're talking 165 kilowatts at 35%, 140 kilowatts at 40%. And at 50%, it's doing roughly 123 kilowatts, but halfway through 50%, there's a ledge every time. And it comes down to about 113 to 116 on average. And then just kind of walks its way down to where at 65%, it's weak, really weak. And it just holds 80 kilowatts all the way to 81%, where it then, which 80 kilowatts at 80%, that's not bad. I just don't know why there's this ledge. And then it just walks its way down to, basically a really long top calibration where it takes almost 30 minutes to complete charging up top. Now, Ryan, you crunch the data on this. You're an EV driver. You know just as much as me about charging curves. How would you describe this curve without the competition in mind? Just what would you like to see improved out of this?
In one word, I'd call it poor. I think just generally not having as steep of a cliff right at 25% is the critical thing. People need to charge up to basically at least 40% at a charging stop, usually significantly higher than that, 50, 60, 70 plus percent. And if you're towing, it's going to be even higher than that. So I think that if you really want to have a usable EV truck, you should have a very meaty charging curve all the way through 50, 60 plus percent. And this simply does not do that.
I mean, we're looking at some of the prismatic cells on the eGMP platform, and I think they use a 622 chemistry, but I could be a little bit wrong on that, but very low resistance chemistry where they allow high power charging up to 80%. Now, they don't have the thermal capacity to handle a deep charge and require multiple sessions to fill this in, unlike Cybertruck, but we're talking 210 kilowatt charging or 215 kilowatt to roughly 75% on the EV9. Whereas, and that's a smaller battery pack. The EV9's 100, it's 20% smaller. And here at 70%, the Cybertruck's doing 70 kilowatts, 69. Actually.
Yeah, I'd say after 50%, this charging curve is not too dissimilar from my Model 3 rear wheel drive. The battery's half the size.
Wow. So, again, this is the first charging curve of the Cybertruck. This is the launch profile. It's probably very conservative. There's probably more they can eke out of it. But again, this is what we're going to review now, and we'll review it as it gets better. And we can overlay the data now and watch Tesla as they hopefully improve the charging curve. Now, my understanding, I've charged Model Y 4680 as well. It's very similar performance to this, maybe slightly worse on a C rate level, but seems very close. And that vehicle with the Gen 1 4680 just sucks to DC charge. There's no way around it. Brandon Flash, a really close friend of ours, of course, is famous for loving his Model Y, except for the charging performance. And that is the most important part of an electric vehicle for those of us who use our electric cars beyond the bubble of our home. And I got to tell you, this Cybertruck charging curve is a make or break buying decision for me. I need a truck that I'm okay. If the range is going to be as low as it is, which they just put a small battery pack in there. So 250 miles it's actually very comparable to the other electric vehicles out there. It's pretty efficient considering it's on 35s, 500 watt hour per mile. Okay. But this is the worst part of the Cybertruck. I mean, I've been gushing over the driving experience and the sound system and the daily driving urban capability. And so don't let anyone tell you I'm a Tesla hater, because I'm sure there's 50,000 people that'll tell you I'm a Tesla shill, which I'm not. I don't own any automaker stock. But ultimately, this is what makes the Cybertruck a tough sell. And a vehicle that's as revolutionary, as next generation in terms of material science and manufacturing should not have it's good, but there should be no but. It should just have a great charging curve. And your Model 3 LFP has a great charging curve. Tesla can do this. Model Y with that BYD battery pack rips.
Oh, wow. Yes.
Yeah.
That one's amazing.
It really is. So Tesla knows what good charging is. And
Yeah,
here they are giving us this crap.
I think it'd be helpful if you could toggle on to see what the other vehicle charging curves are like, just to give it some like context and reference.
Happy to. So, what are we looking at here in terms of stuff? So, obviously, I know this one's Hummer EV, and actually, I think Hummer EV can even do better than this. This was just one of the curves that we have logged, and you can see it just kind of died right here in the middle. But look at this thing,
Hummer EV is
300.
very difficult to get a good charging curve on, but it's especially down low, incredible charging.
Absolutely. And then we have here the Cybertruck coming in with that nice low peak, sitting flat. We have that Rivian R1T. This is with the new 500 amp charging profile, holding power, bigger power, deeper into the pack than anyone else, which is crazy to me because I'm so annoyed with my Rivian's charging curve being awful. And here it is outpacing the competition, if you will. And I think we also owe the F-150 Lightning probably another test here at some point, because I think it can actually do better than we had an early, test truck, a prototype test truck. So a lot of these vehicles, this is what I'm saying, we need to make it fair and really redo a lot of these tests now that we're trying to overlay all this data. But the one thing that is undeniable, Ryan, is the Cybertruck, just from 40% or so onwards, 48% just falls short, except for that top charging.
Yeah, above 80%, it's pretty solid, but 40 to 80 is rough. It's not great.
So, when we start overlaying this data, they're all achieving. We should also probably have a time component in this as well. Just thinking, I'm trying to think, okay, how long is it from 0 to 80% or for 100 kilowatt hours to be added? And so there's more. We have the data. We can crunch some numbers there. And this is certainly not a great way to compare, the user experience of charging, because all people really care about is how much range do you add in a period of time. So thankfully, Ryan has created another chart that you guys are going to like much more, and it's much more fair. We have taken our 70 mile per hour highway range test results and compared them against the charging performance of the vehicles over time. Now, Ryan, this was genius when you hit me with this idea. This is 100% you. Why do we do this?
Basically, charging at different speeds means different things. Yes, the Hummer EV charges well over 300 kilowatts, but the thing's so inefficient. So how does that play out? So I wanted to have a way where you could actually just really compare vehicle to vehicle. I plug in for an amount of time, how far am I going to go? And we've got the data to be able to do that. And I think this is actually a really representative curve. So what you see in the first part is a really steep beginning, indicating really high peak charging speeds. And over time, you see that slope start to decrease over time. And that's the charging curve slowing down. You're getting lower charging speeds as the battery's getting more and more full. And then toward the top, you see it just start to level out as it reaches 95, 99, 100% state of charge.
And what's really interesting about this test is we can avoid the Hummer takes tons of power, uses it very inefficiently. But here we can actually start to see the user experience difference between the trucks. And again, in ideal conditions, as best as we can get them. And honestly, to be fair here, I think we need to retest the Lightning. It's been 2 years or more, and we probably didn't get the best results. We should retest the Hummer, although that one's just so hard to get to charge properly. I don't know if we'll ever get a Hummer to charge well, because they just do these weird swings and they interface very weirdly or interoperate with chargers oddly. And then the R1T is fairly consistent, except it has major thermal issues where you can't get a 0 to 100% charge without smoking the battery pack and hitting, basically a thermal derate. But aside from those, let's talk about the theoretical differences. I'm going to overlay all the vehicles here. And
Before we do that, can I mention one thing is this charging curve is actually sensitive to our testing conditions for the 70 mile per hour range test.
Thank you.
So
yes.
An important thing to know is this charging curve would look differently if we tested in different conditions. So let's say we had just terrible conditions. It was like 0 degrees Fahrenheit. You got massive wind and it's raining. So just terrible conditions for a range test. This would actually have the same shape, the curve. However, it would just be a little bit shorter, kind of compressed. If you Imagine like a picture on a computer and you squeeze the two middle ones and it squishes it. It's exactly what it would look like. And conversely, if you had really great conditions, if it were like 80 degrees, no wind, perfect up here at elevation, you'd expect it to be a little bit taller, stretched out like that image. So keep that in mind. And as you hover over, I've got all that information as far as temperature, wind, tires, all that information. So you can try to compare them, but it's important to keep in mind that we didn't test these right next to each other. So 70-mile-per-hour ranges do vary a little bit.
And this is where I think kind of our numbers, when we start getting into the real granular detail, start to fall apart at the moment, in full transparency. I have no question our testing procedures are better than any other outlet on YouTube. However, we still deal with real world conditions. And both Ryan and I are so particular about these numbers that we're like, how do we build a laboratory that we can run all the vehicles in the same conditions? And honestly, we are working on that. We've had conversations with dyno companies. Our office is at Colorado State University. They want to put a laboratory in their new building. I'm like, I need to do instrumented range testing because our audience are super nerds. And like, these are, we're talking multi-million-dollar laboratories just so we can dial in these numbers. But we're nerds. This is what we love. And so right now we're relegated to the real world. Right now we've had different ending points of charging. I'm actually working on a way that we can run every vehicle until they stop moving completely at 70 miles an hour, just to make things more fair. So consider 2024 the next generation of out of spec testing. And we have to kind of redo some of the older vehicles. So Ryan, great points there. As I overlay these vehicles, we have to keep in mind the different conditions and tires that we've run on each of them. For example, we used the Rivian R1T on the 20-inch wheels here. However, we've recently also just run a large pack and a max pack on 21s. We don't have that data in here yet, but it'll be added soon. So let's overlay all of the trucks. Ryan, tell me what we got going on here. What is all this?
So essentially in blue, we still have the Cybertruck. And what you see is that in the first 10 or 15 minutes, it's keeping right up with the Hummer EV. And that means they charge at effectively the same rate when it comes to usable range. It's also considerably higher than both the Rivian and F-150 Lightning, meaning it charges considerably faster for the first 25 minutes or so. Interestingly, you can actually see pretty clearly right around 20 or so minutes, 25 minutes-ish, the Cybertruck is starting to fall off and flatten out that curve a lot faster than the other vehicles, and other vehicles are catching up to it. One thing that you could do is the time slider, you can move that over to the right to increase the range of time that you're looking at. And as you can see, the other vehicles just start to catch up. And that's what we're talking about when we talk about not the best charging curve. But I think the reality is, looking at that first part of the curve, it's actually really good, considerably better than the Rivian and the Lightning, comparable with the Hummer EV. And even when we start getting towards the higher states of charge, it's fairly close up until you're doing like 40 or 50-minute charges. Then there's a considerable difference. But I think real world, generally speaking, when you're road tripping, this is going to be pretty solid and fairly competitive with the other vehicles. Despite all the time we just spent bashing the curve, I do think that it's still performed decently well. And that's because it's able to make up for the only decent or relatively poor charging with okay efficiency.
Yeah, ultimately, I think it depends on what kind of driver you are. Actually, for the out of spec style road tripping, where I love getting the chargers completely dead and then just ripping on the charger until it, about 40% or so in this one, and then hopping charger to charger to charger, assuming you have the infrastructure to support it. The Cybertruck is great. And, in that case, by great, I mean in comparison to the other vehicles here. Now, is it great compared to the overall car market? We're going to pull that up in a second, actually, and just make this, bring home a different sentiment here. But we're comparing it against its competition. The one vehicle that I'd really love to get on here is the work truck Silverado EV with the giant battery, because that should be significantly more efficient than the Hummer with the same charging performance. And that thing is just going to freaking rocket. I mean, that's a 450-mile EPA range truck.
I've played around with some of the curves to see what it would look like if it got like 450, 500 miles, and it's impressive. I'm
Yeah, for
hoping we
sure.
can get that in as soon as possible because I'd really love to see that. I think that would be up there with one of the best charging vehicles that we've had.
I totally agree. And actually, when I was driving it, I was kind of beating EPA on the highway at 70. That might actually be a real 500-mile range truck. Now, at the end of the day, GM doesn't seem like they can produce any electric vehicles, so it doesn't matter because you can't buy the damn things. But it is cool to see this differences out there. So
Yeah, GM
this is,
EVs are great in theory.
yeah, that's right, in theory. Yeah, they're leading the way, Ryan. Don't forget, okay? But I mean, like, actually, that truck, if you can get one, if you only need one, then that might actually be a fairly usable vehicle. The thing is that when I saw this chart, this is when I was kind of like, oh, okay, well, maybe it's not as bad as everyone's been saying online or me thinking in my head. But then I also think like I'm also complaining about my Rivian all the time, and I'm complaining about the Lightning charging all the time. And the only reason I'm not complaining about the Hummer all the time is because it literally cannot charge any faster than current equipment can give you. It's just so thirsty. So ultimately, what I think we've learned is Tesla has come in mid pack, roughly, when it comes to the user experience of charging. However, I think the offset of the split pack nature and interfacing really well on current superchargers probably still makes it the better road tripper than the other vehicles.
I can definitely agree with that. And to be fair, there is a lot of improvements that they can make with software. And allegedly, there may be up to 350 kilowatt charging someday. And if that is the case, this curve will look very different.
Yeah, and the thing is, if they do 350 kilowatt charging, assuming the current curve, which is this one right here, it's only going to get you there till about what 20% or so, because it's going to peak
Maybe.
here, but this is where it comes off of 250. So it's going to have that same crossover section, assuming they don't push the cells harder. Which knowing Tesla, I think they really didn't expect anyone to test the truck like this at this time. It's probably pre-release software. It's probably not ready. I'm just speculating at the moment. And I think there's a lot more they can unlock with this thing, especially having a very similar charging curve to Model Y 4680, but with a newer generation cell. So I'm thinking, okay, they're playing it safe. They're going to unlock it. Don't freak out yet. Let's just keep an eye on this space very closely. And really, ultimately, I think my disappointment comes from I was hoping Cybertruck. I knew that Tesla was going to put the smallest battery in they could to sell it, but I was hoping they could compensate with really good charging for really the first time on any NMC chemistry that they've delivered. The answer is not, at least at launch. It is a pretty weak sauce part of the truck. And I'm saying that, yeah, in comparison to Lightning and Hummer and F1, yeah, whatever we're talking about, these vehicles, R1T, it's not blowing them away, but it's also not way under the pack. Lightning, actually, according to this test, is the underdog. But somehow I just have a feeling that maybe they've improved Lightning, or maybe this feels artificially bad. I don't know. What do you think?
It's possible. I believe they still are using that 10-minute timer where you only get your peak charging speeds for 10 minutes.
But then shouldn't we include that in the theoretical maximum charging test?
It is.
Okay. So we did
Yeah.
have that in there. Okay. So this
Yeah.
is maximized out. Okay.
You
But
can
let's put
actually
this.
see the first 10 minutes. The Rivian and F-150 Lightning are super close.
Oh, really?
Yeah.
Um, so what is this
Sorry, you have
vehicle
to
here?
zoom out. You got six
Oh,
minute time.
oh, okay.
There you
Okay.
go. You go up to
So the Bolt
90
is,
minutes. There you go.
oh boy, the Bolt.
The Bolt.
This is my first time looking at this chart. This is fascinating. What's the best one? What is this?
Model S Plaid.
Model S Plaid,
I
EQS. Do we
I
have
think
Lucid?
that we do not because we did not do a 0 to 100% charging test with it.
We never did a charging test on a Lucid?
Nope.
What?
Right? I was shocked.
I definitely did tests.
It's not
It must
a
not be posted.
yeah.
Okay, and each version uses some slightly different chemistry. Okay, well, we really need to get a Lucid in here because my impression is the efficiency of
Lucid
that
should be up
car.
here.
Lucid should be right up top, would be my guess. I mean, these guys know what the heck that car's built for distance. When it has the
Yeah.
infrastructure to support the car, that thing will rip. So yeah, my problem, I guess. I apologize to anyone curious how the Lucid performs here. that's a wake up call. We really need to get that car in. So if anyone at Lucid is watching, send us a car. We need to relog everything, and we want to do it
Ioniq
properly.
6 rear-wheel drive as well. I think that'll be another exceptional vehicle.
Yep, absolutely. Wow, and the Mercedes stuff doing nice
as well. It's pretty efficient.
Okay, so EV6 GT we knew was going to be a monster. I'm just looking up here. iX. Wow, all the German stuff, which is like not big peaks but good curves, does well for the deep charges. And then the stuff that I'm kind of curious in would be like we zoom into this 30-minute window range.
This is the most interesting part.
Yeah, so this is where I like to charge. Realistically, I like to charge about 25 minutes, let's just say. So here we have huge separation. We have Model S Plaid. Damn, that's crazy. Lucid, I bet, would beat that one easily. We have EQS SUV. Are you kidding me? We have Ioniq 6. We knew that was going to do well. EQS, Taycan, we knew was going to be right up there. Surprised it's actually that kind of poor, but that was on the Cross Turismo. What about the sedan? Maybe we don't.
Still actually need to. We haven't tested that one. We still need to.
Well, couldn't we take the Cross Turismo charging profile and apply it to the sedan's 70-mile-per-hour test?
Yes, but we don't have one from our Colorado route.
Oh, this is just using the Colorado loop.
Yes.
Okay.
Yes, that's correct.
So maybe okay. So that could be also why maybe some Lucid stuff is not in here.
That is very possible. Yeah.
Yeah. Okay. And maybe our viewers just now we're nerding out for a sec. I know that, gosh, I said this was going to be a quick video. We want to only use our test loop in Colorado because of the air density. It does make a difference. So GV60, yes. All the EGMP stuff is right up here. Wow. ID4. What the heck is that doing up here?
Yeah. The ID4, I think, is really, really solid middle of the pack charging. If you're looking at a bunch of crossovers, it's just dead in the middle.
Wow. And then we jump down to the trucks. So, and BZ4X. Whoa. So wait, yes. Does the BZ4X beat the Cybertruck?
It's pretty darn close.
How do I zoom in on this?
You could do control.
Wait, here's Cybertruck and here's BZ4X. So at
24 minutes, 25 minutes there.
25 minutes. It's R1S, R1T, Aria, Cybertruck is 142.2. Oh, thank God. Cybertruck beats BZ4X.
Barely.
When I'm complaining about the charging curves, I'm not comparing the Cybertruck to the other trucks in its class because they all suck. And that's what this shows.
Yeah. Trucks, it's the efficiency, really. I've looked at the data a lot, and it's really sold me on how important efficiency is. And then, of course, another huge factor is sometimes chargers are limited, and that's where efficiency really has a ton of benefits.
Look, there's no replacement for displacement. I mean, efficiency. And so essentially what we've learned here is I love this data. I really want to comb through and make sure this is all accurate. I really want to get the big vehicles in here. Lucid has to be. We need that data because that should set benchmarks in a lot of this stuff. So really need to get Lucid in here. We really need to get all the Teslas logged. So if you have certain Tesla models in Colorado, obviously, let's get them in there. Let's do charge tests. Let's do a range test. And let's just hammer out as many as we can to throw as much data in here. Let us know what you think about all of this visualization. To me, this is fascinating. And we are talking about a big gap from like normal vehicles to these trucks. Huge difference in range here. I mean, the difference in range is so significant that a Model S Plaid is doing 250 miles for the same time charging that a Cybertruck's doing over 100 miles less.
Yeah, another way to think about it is a lot of other vehicles could plug in at the same time and then leave to go to the same destination after 10, 12 minutes while the Cybertruck's there for 25 minutes.
Right. Or any of the other trucks, to be honest. So yeah. I'm really hoping we really got to get that Silverado work truck in for sure. See what that thing does. The Bolt, man, don't road trip a Bolt. This is why.
Yeah.
God damn. It's
brutal.
Was that an EUV? Okay. I don't even remember doing that one. Did you do that one?
No, you did it.
What? That must have sucked. Must have
It did
erased.
actually. I mean, the range is decent. It's like
Yeah,
250 or 220 or something.
it just takes like 9 years to charge the damn thing.
Yes. Yep.
Okay, well, I hope you guys enjoyed this 1 hour long episode charging the Tesla Cybertruck. It really genuinely was supposed to be 15 minutes. I cannot get these short videos for you guys, but I'll try and break it into chapters to make it easier. Could have left you known that up front. Can't thank you enough for watching our Cybertruck coverage. I think we just have 1 or 2 videos left from our time in Austin. To me, this was the most important. It's certainly no better in any measurable, meaningful way than the other electric trucks out there. However, having access to the Tesla supercharger network is good. And is a native advantage at the moment. However, not having access to third-party CCS stations certainly is a disadvantage, because it's just great to know I can plug in a Tesla anywhere on superchargers or public stations. And I think there's a lot of communication things Tesla needs to do to sort out the high voltage charging on third-party natively. Plenty more tests for me to do. I wanted to interface a 1,000-volt NACS connection and see if that would work. My guess is no. I think Tesla's just locked it to single wire communication. And even though it says CCS enabled, it just won't let it speak 15.11.8. Just my guess. So any
More
last
testing
comments,
to be
Brian?
done.
Yeah.
No, I'm really excited about finally sharing all this data with everyone. I'm excited to hear what everyone has to say.
Yeah, same here. Thank you so much for watching another Out of Spec Reviews video, and we'll see you on another one again soon. Bye-bye.